Hello.
Hey, how you doing?
Good. Looks like you figured out the recording.
Yeah, I got it recording and I think we're ready to go. I'll turn the lights off behind me. I can see that that's a problem.
Yep. Your connection's really good, it looks like.
Good.
You plug it in to your Ethernet cable?
Yeah, it's plugged in. All right.
You talk too much.
What is that?
That's my text message. And it's good that I have it on because last week when nobody could hear me, you texted me and it got my attention. I was talking too much. I needed to figure out my text stuff. But
I heard that, and I was looking around trying to figure out who was unmuted and telling you talk too much.
You thought somebody was telling me that. That's hilarious.
I was trying to be a good tech guy and go through and find them.
That was me. Sorry.
Oh, that's okay.
It made people laugh. If they didn't laugh, they didn't have a sense of humor or they didn't hear it. One of the two.
Yep.
Okay, it looks like we're getting people in. Ezekiel DeMille is my son. He is on here tonight. He's going to take care of the computer. He's going to let people in. He's going to ask me questions. So this will be fun. Type where you're from in the chat box. Tell me what state you're from. When you ask me questions tonight, remember to type those into the chat box and then tell me what state you're from so that I can try to answer your question appropriately. If you're gardening in a greenhouse or if you're outside, that would be helpful information to know when I answer your questions, because your greenhouse is a different climate from the state you live in. And it is about time to get started here. So here we go. Okay, so just a couple of things. I'm going to take 3 or 4 minutes and I'm going to talk about me and what I'm doing and trying to help you have the best gardens in the world. And then our subject tonight is all about the 4 ecosystem processes or ecological processes and what that means and how it deals with your environment and how it will affect your garden. So that's our subject tonight. But first of all, if you are serious about figuring out how to grow food to feed your family this year, you need to come to my boot camp. It's on this slide right here. And that's coming up the last week of April. So it's coming up pretty quick. Sign up for that. Come to Clover Valley for 3 days here where I live. It's just 16 miles south of Wells, Nevada. It's a 3-hour drive from the northern Utah Wasatch Front area. And you will go home knowing how to grow food. I have simplified this. So what you will do in the 3 days, you don't have to know anything about growing food. I will show you seeds. We will make potting soil. We will plant the seeds. We will transplant bigger seedlings. We will create a garden outside. And I will show you how to grow food for your family. So this is our boot camp. We did it last year. It was excellent. We had people come who have not grown a lot of food. They went home, they had successful gardens. We had other people who came and had a good time. They went home and they didn't grow a garden at all. And that's okay too. Of course, I have my Patreon videos. If you don't or can't come to the boot camp, $8 a month gives you a subscription to over 300 posts on my Patreon page. And most of these are how-to videos of me in my garden showing you how to grow food. So once you pay that $8, you have access to all of that. So you can sit down and you can watch all of those, and it can be a great help to you to know how to grow food. And then throughout the summer, we have a lot of other classes. If you are a college-age person, or if you know a college-age person, you should seriously consider our 17-week farmer training program if you want to grow up and be a farmer. That's what I want to do when I grow up, but I'm not that mature yet. So anyway, but that's all we're going to look at on this slide. Let's move down here and see if I'm smart enough to run this. It could be a challenge. Okay, here's a picture of me and my wife and Jared Sorensen and Selena Sorensen. We are the teachers for these classes. Depending on what class you pick, it will either be all of us or part of us. And then this is what student housing looks like on our ranch. This is pretty exciting. Think about being 18, 19 years old again. You could come live in a sheep camp for a summer and I will teach you everything I know. And then let's move on. We're going to start with this slide right here, this earthworm. Can you see that? Is everybody good? We're good? Okay, thank you. I'm going to minimize this for a second. And we're going to make this bigger. Last week, we had a question about earthworms. And the question was, how do you tell if an earthworm is mature, if they are an adult earthworm? Well, this shows us how. I took this picture this morning, actually. Hopefully you can see my cursor right here. But this is the mouth of the worm, this pointed end right here. And as you come back, there's this lighter colored portion. And on most worms, it's swollen, it's bigger. On some species, it may not be bigger, but it is a different color. On almost all mature worms that I've ever seen, on all species that I know about, this is a different color, and it's usually swollen. This means that the worm is sexually mature. It is an adult, and so that's how you know. So this is trying to answer your question a little bit better than I answered it last week. But this is called the clitellum, and this is the sexual organ of the worm. And anyway, there you go. If you have more questions about worms, we can certainly talk about those more. But let's get going with our subject for tonight. And so this is our second class, and this is recorded, and this will come out on YouTube in a couple of days once I get it uploaded to YouTube. But our class tonight is about the 4 ecosystem processes. So all life on Earth is driven by the sun. And this process, we call it energy flow. The scientific community calls this energy flow. They could have some other names for these, but this is the one that I am used to. So there is no life without the sun. And this is important to understand for a lot of reasons. First of all, it's important to understand ecologically, because sometimes we think that plants are getting light when they're in a well-lit room in our house, and then they get really long and they're reaching towards the window, and we wonder why they're long and spindly. Well, it's because they don't have light. They're trying to get to the light. And so from a gardener starting out, a lot of times people will make this mistake. They want to start their tomato plants or whatever early in the year. And so they get them going, they have them by the window, and then the plants are leaning toward the window. So I'm just going to tell you right now, if your plant is leaning toward the window and you're turning it back and forth every day, like you're turning the tray or the pot back and forth, and it keeps going towards the window, that plant is telling you it does not have enough light from the sun. It simply is dying. It's starving to death. It may be green, it may be growing, but it's not growing as good as it should be if it has that that tropism is being, if it's showing that, if it's exhibiting that tropism of going towards the light, then you know that you need to have additional light for those plants. So that is one example of energy flow and how it affects us as gardeners. And there could be dozens of others. Long cloudy days, the summers that have lots of smoke from forest fires, and the UV lights are not coming through properly through the smoke or the haze, or even in a polluted area where there's a lot of light that is being blocked out and it's not penetrating. Our plants will not be growing as good as they could be. So there's a lot of different factors that can stop that energy flow from the sun. But there's another thing about energy flow that is more along the lines of financial. Financially, energy flow is important for farmers, usually people who are using fossil fuels. Because when we think about this ecologically, a fossil fuel is ancient sunlight. Plants photosynthesized a long time ago, maybe a long ways away, and they have turned into fossil fuels. Now, this is an interesting thing because if we are using a lot of fossil fuels to create food now, that's going to cost us money. So if our fertilizer bills, which are they're made from lots of fossil fuels, our pesticides, those are made from fossil fuels, herbicides, which are also made from fossil fuels, and then obviously if we're burning diesel fuel in a tractor, that's a fossil fuel. And then there's a lot of other things. The list could go on and on here, but those are the big ones. Fuel to run our tractors to create food, and then the fertilizer, the pesticides, and the herbicides. Those are the big ones. Those are created, and it takes a lot of fossil fuel to create those. So we may not see that impact if we are a backyard gardener, but we do see that impact when we purchase food. When we go to the store and we see the price of food, it is impacted because of ancient sunlight, that ancient energy flow that was turned into fossil fuels. And now we are using those fossil fuels. It takes a lot of ancient energy to create that. Now, the United States has been pretty insulated. We don't spend a lot of money. The last report I've seen is somewhere around less than 10% of our income goes to purchase food. I know a lot of Americans still, and we buy food as recreation. It's a recreational thing to eat, to go out to eat, to buy fun foods. So we don't really see the impact that other countries have seen. But a lot of countries spend 50, 60, some countries will spend 70% of their annual income just to eat. And sometimes people are working today to buy the food that they're going to eat for dinner tonight, and they eat once a day. So we are very, very blessed in this country. But we need to understand ecologically that this energy flow has a lot to do with this entire economic system of the food that we eat and how much it costs. Now, let's talk about something that is important about energy flow in the United States. And that is farmers who have suffered and struggled over the years to make a profit. You know, it's interesting. One of the biggest things that money goes to in the from the federal government, the federal spending that happens, goes to the Farm Bill. But we don't hear about it very much. We hear a lot about education. We hear about defense. We hear about a lot of things, but we don't often hear a lot about the Farm Bill, which is interesting. And I don't know why that is, but it's interesting. And we won't go into that because it will take way too long, and that is not our subject tonight. But the reason I'm bringing it up on this slide about energy flow is because our modern farming system in the United States that feeds us. And this is why the grocery stores are full of food and restaurants have food when we go to order something, is because we use mostly ancient energy flow, meaning fossil fuels, to grow the food we grow. And we have figured out a way to do it so that food is basically cheap, but it is not cheap ecologically, and it is not cheap for the farmer because the farmer doesn't get paid very good, and farmers go out of business. In the 1980s, there was a mass exodus of family farms, and there have been a lot of those throughout history of using fossil fuels. There's an exodus happening right now. And it's interesting because the people who are understanding current energy flow from the sun, those are the people buying up the farms. See, in the 1980s, the family farmer was dying and they went out of business. And guess who bought the farmland? It was mega corporations. But today, the family farmers are dying, and guess who's buying the farmland? It's two groups. It's still the mega corporations, but it's a new set of farmers who are doing this new type of farming, and they are not using very many fossil fuels. There are millions of acres of American farmland that are using the current sunlight to grow their own cover crops, which translates into fertilizer. And they're not purchasing fertilizer. And because these new farmers have like a really diverse ecosystem, and we'll talk about that on another slide in a second, but since the ecosystem is diverse, they are capturing more photons coming from the sun, hitting the leaf. It's putting more carbon into the soil, which means fertilizer, more biomass on top of the soil, which means fertilizer. And it means that there are more beneficial insects, and so they don't need the pesticides, and it's stopping the weeds from growing, and so they're not using herbicides. And with innovative equipment, they can plant in one pass and they're done, instead of tilling and then spraying and then planting and then spraying again. Now they only have one pass through the field with their tractor, and so they're eliminating a lot of diesel that they're burning. Now farmers are becoming profitable again. And we will talk about this more in future classes. But right now we are going to move on from energy flow to the second ecological process, but let's just go to succession. And these are not in any order. We could talk about these in any order and it's okay. So this is the second one I've chosen today. This is ecological succession. So what in the world is that? Okay, ecological succession. We have to think about bare ground, bare earth. If you think about geology, when does new ground get formed? Well, there's a lot of things that form it, but let's just think of a volcano. I think a lot of people know about Hawaii having a volcano, and there's just bare rock out there. It's a common thing for college kids who are going to BYU, Hawaii, to go out there and they're walking on the volcano and it's nothing but bare rock. But so if you look at I'll get my cursor out here. Let me just make this big for a second. So if you look over here, we have mountains. I'm pointing here with my cursor. We have big boulders. We have bare earth, because this was just formed. Let's pretend that this is nothing but rock right here. So this is your earliest succession, and that is bare rock. And then I want you to look at this line right here. There's this line right here that's coming down here. And this indicates the topsoil, how thick the topsoil is. So when we have bare rock, it's just bare earth, bare rock. There is no topsoil at all. So this is early succession. And when we're looking at ecology, what happens to create thick topsoil, like on the right side of this screen where the trees are growing? What makes that deep topsoil? Because that's what we want in a garden, is good topsoil. So the first thing that happens in Mother Nature, in ecology, is on rock will start growing mosses and lichens. Mosses and lichens, and then annual plants will start to grow. You'll start getting a few little tiny plants. And then later on, 10 years later, you'll be getting a lot of annual plants. And then all of a sudden, a perennial plant will start growing. Guess what? We're getting into mid-succession. And then the soil is starting to get thicker. And our perennial plants start growing. We start getting things like grasslands. And we have beautiful prairies where the same plants grow year after year. And eventually, we will start getting bushes. And once we get over to this right side, we will start getting some trees growing. And then we get more and more trees, more and more bushes. And we have less and less of the perennials, the perennial grasses and the perennial flowers, but we will have really thick forests. Now think of the redwoods. How many of you have been to the redwoods? How many of you have been to a jungle? Maybe even the jungle on Hawaii would show that late ecological succession, because Hawaii certainly has the brand new forming rock and it has the old growth jungles. And so we have all successions happening in the Hawaiian Islands. And so it's an easy place and a fun place to go. If you go to the Big Island, you can drive around the Big Island and you can see this entire ecological succession happening in one day by driving around and looking at different stuff. So why does this matter to our gardens and to growing food? Well, this is extremely important to growing food because most food crops happen in mid-succession. And so if we want our food to grow with less weeds, less pests, and less fertilizer, then we want to grow in mid-succession. Because look right here at this chart. We have pretty thick soil here, and we have perennial crops growing. So we have really beautiful crops. Like so what would a crop be that would grow here? So like wheat, oats, rye, barley, those would be things that would grow here. Now those are annual grasses, but they will grow really good kind of in this early mid-succession. They do really well right here. Now, obviously they're not a perennial, but you can have a lot of annual grasses in this area towards the end of early and the beginning of mid-succession. So what do we do as a farmer? We go out there, we get on our tractor. Now, what do we do as a gardener? We go out there and we get our rototiller. And so we're going to till it up. What happens when we till the soil? We change succession from this early mid succession where our garden crops will thrive, and we go backwards to right in here where my cursor is. It goes backwards right here where the annual plants are going to grow. Even if we have really deep soil, let's say that this used to be a forest and we cut down all the trees and we have really thick topsoil. Well, you know what Thomas Jefferson said? I love this quote. He said, this is not a quote, I'm paraphrasing, but he said, we can farm a piece of land for 15 years and then it loses fertility and we don't know why. Well, with science today, we know why. We can answer that question. Thomas Jefferson didn't have all the great science advancements we have now, but it's pretty awesome. Now we know that when we till the soil, we kill the mycorrhizal fungi, we kill other types of fungi, all the beneficial fungi, they start to die. And when they die, we make the soil in an early successional state. And for ecology to try to fix the early successional state, it will create more bacteria will start growing because we stimulate the bacteria growth when we till, whether it's with a tractor or a rototiller. And when we have a lot of bacteria growing, the annual plants will sprout. Guess what an annual plant is? Those are all the horrible weeds that grow inside of our garden. So if we could have a different method to grow, and we could keep our succession right here, and we were never tilling the soil, then one of the hardest jobs there is to till, and one of the most costly is to till if we're talking about using a tractor. Then so we till it up every year, and we are causing weeds to grow, and we are killing fungus, which creates one of the best fertilizers for our crops. All right, let's move on to the next slide, which is right here, the water cycle. Okay, so this is our ecological principle number 3, okay? So number 3 is water cycle. Our water cycle simply has to work. If our water cycle is not working, we are not going to have healthy gardens, healthy food, healthy families, healthy anything without water cycle. So over here we have evaporation from the rivers, the streams, the lakes. All that evaporation goes into the air. That's what it's supposed to do. And it does it very well when the sun hits it. There's also another form of evaporation, and it's right here. It's called transevaporation. And that comes from plants. It comes from grasses and flowers and trees and shrubs. All living plants will transevaporate the water that's in the soil. It goes through the roots into the plant and out of the plants into the atmosphere, just like evaporation directly from water. And that's what it's supposed to do. And then it forms clouds when it condenses. So we have condensation, and that creates rain and snow and sleet and fog, any type of precipitation where the water will come down and it creates dew, water, whatever, onto plant surfaces, the soil surfaces, and into the water. Anytime that the precipitation comes down, then it starts over with evaporation and the cycle goes around and round. This is a really great cycle, but why do we need to understand it to grow good gardens? Because our gardening and our farming techniques, they matter and they affect this water cycle. The way we do things will affect this water cycle. Now, there is something I left out of this cycle here, and I'm going to tell it to you right now. It's called infiltration. My son lives, he's on here tonight. He's hosting, or he's the co-host here, letting you all in your room. His name is Ezekiel. He lives in Enoch, Utah, which is right next door to Cedar City, Utah. And last year, they had a really bad drought, like most of the Western United States is in a drought. And later in the year, I think it was either August or September, but they had 10 inches of rain within a day. It could have been within hours. And what happened? 2 weeks later, people were watering their lawns and they were still praying for more rain. But with 10 inches of rain, I saw on the news, and I saw some YouTube clips that people put on YouTube. In that storm, there were cars that were floating down streets because it was a major flood. It was a disaster. There were millions and millions of dollars worth of damage to businesses, to homes, to the communities. The 10 inches of rain that came down all at once was a bad thing. Okay, it was a really bad thing. And can we affect that? And most people would say, no, we can't affect that. You know, maybe we can't affect 10 inches of rain all at once, but there is something in this cycle we can absolutely affect, which we are not affecting, and that is called infiltration. So I'm going to take my cursor over here, and it's up here on this cloud. And when a raindrop comes down, my cursor is a raindrop. It's coming down. It hit this tree and it bounced off, and it hit the next one, and then it hit the bush, and then it hit the ground. And when you get 10 inches of rain, most of that rain, if you have good infiltration in your soil, it should go into the soil. It should infiltrate. And people say, oh, we have such a runoff problem. The water is running off our fields. It's not soaking in. The water is running into the streets. It's running into the rivers. We're having flash floods. This is something that just always happens. That is not true. That is something that can happen, and it happens in areas that have desertified, but it does not have to happen. This is a mistake we are making as human beings because we are not creating soil that will infiltrate. So I argue that we do not have a runoff problem. What we have is an infiltration problem, and we need to learn to create soils that will infiltrate. If we could have infiltrated 5 inches of that rain, and then the remainder of the 5 inches ran off, we probably would not have had any erosion, and we probably would not have had a flood that was as serious as it was. Okay? And 2 weeks later, people would not have been watering their lawns if the rain would have infiltrated, because 5 inches of rain would have kept things watered for a lot longer than that. Your grasses and your croplands, pastures would have stayed greener longer. Now, people always argue with me at this point, and they say, maybe not always, but 99.999% of the time, they argue with me at this point and they say, but it has always happened like this. It has always been this way. And my answer to you is yes, I know. In our lifetime of people who are alive today, we have lived in the Western United States in a desertified condition. And that's why we don't understand a different way that it can be. But I have seen different ways that it can be, and that's why I'm teaching these classes, is because it is so important, and you can change this in your gardens and in your landscapes. Okay, let's move on to the mineral cycle. So this is number 4. This is the mineral cycle. So this is our 4th ecological principle, and the last one. There are 4 of them. So here is how this works. Well, okay, here we go. I need to quit touching my screen. All right. So the mineral cycle. This is super exciting and super fun and super thrilling. The mineral cycle is exciting. Okay, here's the deal. The mineral cycle is driven by photosynthesis. So it is driven by the first slide we talked about here, the first ecological principle of the sun coming down, which was called energy flow. But without energy flow, none of the other cycles work. The water cycle stops. The mineral cycle stops. It all stops. It doesn't work anymore. So here's how the mineral cycle works. Plants photosynthesize, and then they create 2 things from photosynthesizing. It creates more plant matter, and there is the microbe food is that plant matter that feeds the microbes. And you can see that big list of microbes over there. Earthworms are not necessarily microscopic, but the rest of those are microscopic on that list. So the 2 food sources for these guys is the plant material that's created, and then it's something that is invisible. We can see it with microscopes, and you can see it if you get really lucky and the light is just right and you're digging in the soil. And those are the exudates that come out of the root hairs on the plants. So the root hairs go down in the ground of all living plants if they have roots. Some plants don't have roots, but all rooted plants, the roots go down in the ground and photosynthesis happens. Liquid sunlight is created in the form of sugars. It goes down into the roots and it is pumped into the soil. And we call that sugar. We also call that carbon. So the carbon comes from the air. It goes into the soil through the roots. Fungus holds it in the soil. And then the microbes eat it And then the bacteria, the function of the bacteria is it will decompose part of the sugar and part of the plant material, like the leaves, the stems, the barks, root hairs, the actual root mass. And when it decomposes it, the bacteria blows it off and it goes back into the air. And that's the way it's supposed to happen. And it happens through decomposition. So the organic matter feeds the microbes, and the plant roots, the exudates of the plant roots, also feed the microbes. Okay? And so that's where they get their food. There's another very important thing that happens that we need to understand in this mineral cycle. And that is the fact that during this decomposition process, the bacteria and the fungus produce these chemicals that will melt rock. All soil has sand, silt, and clay. And scientists are finding out that pretty much all soils everywhere throughout the earth, and there could be some real microclimates that are a little bit different, but for the most part, like 99.9999% of soils, and for sure all the agricultural soils of the earth, they have all of the nutrients needed for plant growth. So we don't need to add fertilizer to grow really healthy plants. When we look at ecosystems like the redwoods or like the old growth forests in other places all across the world, those produce more calories per day than any other systems. Now, they're not calories that are fun to eat. We don't just pick up a tree branch and start eating it. We as humans don't recognize that as a food source, all right? But what we do see as a food source are the obvious things that we eat. But we cannot, in those mid-succession states that we just talked about, when we're looking at food from those mid-succession, that's where we find most foods that we recognize as food. And so we want to create a mineral cycle that is thriving in a mid-succession state. We're capturing lots of the sunlight that's coming, and our water system is working. When that happens, most of the work of creating food is taken out of the equation. And this is real, this is true, this is just science. Does it mean we don't have to work anymore to create food? No, it's not. Doesn't mean that. But it means that if we work correctly and we do the same amount of work, we can create a lot more food than we were creating before. And it's a lot less expensive because we don't have to buy all the expensive man-made things to create that food. And it's because we understand these 4 ecological processes. And if we don't understand these processes, we need to continue to study them and to keep learning about them and how they apply to my garden in my backyard or my farm or my big giant food producing system of thousands of acres. The more we know about these 4 ecological processes, then the more profit we can have from the food that we're selling, because our inputs are lower. I have an acquaintance in, where's he at? He's in Minnesota, I think. He farms 40,000 acres. And he raises mostly corn and soybeans, a few other crops. And he was spending $500,000 a year just on fertilizer. And he didn't have enough money to take his kids to the dentist or to take them on a vacation to Disneyland or anything else that people wanted to do. And he started doing this type of farming 6-7 years ago. And he started growing his own fertilizer in the form of cover crops. And he sold a lot of his equipment. He got smaller tractors, and he's burning a lot less diesel fuel. And I think this year, he said that, because he was saying in a couple of years, so that would be this year, he would be completely out of debt. And after 3 years, his fertilizer costs were almost at 0. And here's the interesting thing. the amount of food he produced per acre, in the corn world, we call that bushels per acre. It was less than he was producing before. Okay, so he's producing less food, but he was making a lot more money because he was saving so much money by not buying fertilizer. Can you imagine if you're a business owner and you spend $500,000 a year on something, on an expense? Of course, his was fertilizer. But imagine that in a 3-year weaning process, he weaned himself off of that in 3 years. Now he has $500,000 to do something else with. Well, a lot of that became profit. And he had other things he was saving money on. Instead of 6 passes through his fields, now he has 2. He goes through the first time and he is he's rolling down the cover crop and he is planting, and that's it. And then in the fall, he goes through and he harvests and he scatters cover crop seed at the same time. And then that cover crop seed grows in the fall. And then in the spring, he harvests it. So instead of 6 passes through the field, he's doing 2 passes through the field. Now, he's not doing that every year on every field. In some fields, he has 3 passes, because I think in the corn that gets harvested later, he goes through with a big machine that's really tall, and it plants the cover crop before the corn is ready to harvest. But still, it's only 3 passes instead of 6. So there are amazing, wonderful, beautiful things happening in the world of agriculture because we are understanding these 4 ecological processes. So now let's open this up for Q&A, and we can certainly talk about how these processes affect our gardens. See if I can minimize this a little bit here.
I have a bunch of questions written down here from the chat and from some people who wanted some questions answered but weren't able to attend the seminar.
Okay, good. Go ahead and ask me the questions, and we will we'll just get started.
Okay, I'll just get them in the order that they were given to me.
Perfect.
So the first one's a little long. For people that care about regenerative agriculture and have read all the documentation about the importance of herd animals and ruminants as part of the regenerative process, but who can't get them because of land or money issues, what do you suggest for a healthy kind of a cycle there to replace those?
Okay, perfect question. I'm glad that question was asked, and this is very important because this is for, the answer is going to be for people in a city. You can't have a cow in your city. It's against the ordinance, okay? Maybe you can have a chicken, and if you have chickens, they can fill part of that role. But here's the answer. You need to start composting. Now, what is better, having the cattle or having the compost? I will tell you, the science we know now, the best science we have, is that the cattle will have better diversity, better plant regrowth after the cattle have been there. Cattle are the best tool there is. And it makes sense from an ecological point of view when you look at how soils were formed through grasslands and bison and wildebeest and the big animals going through. But if you can't have the cattle, then you need to have the compost, because if you make a really good compost, and if you need to know how to make compost right now, it's long, it's too involved for this free class. Pay the $8 for the Patreon. Go on there, watch all my composting videos. It will take you through day by day on how to create the compost so that it'll be good compost. But in a nutshell, here's what you do. You create the compost, and when the compost is done, you would take a handful of that, like 1 or 2 pounds. So it's just a double handful like this. You put it in a 5-gallon paint strainer bag. I wonder if I have one right here. Here's the paint strainer bag right here. So this just goes in a 5-gallon bucket. You can buy these at any hardware store. This one has a hole in it. But anyway, you can get a package of these super cheap, like 20 of them for $5. And so this is a really thin mesh. you put your compost inside of this, and then you put this in a 5-gallon bucket. Now, the 5-gallon bucket will be filled with water, maybe up to like right here. And this has the compost in it. I was not planning on doing this.
You should pull your camera down a little bit lower.
Here's some compost. I bet none of you have compost in your office. Okay, can you see this, Ezekiel?
If you pull your camera down a little bit, like pull your laptop closed just a touch, it'll be easier.
Like, are we good now?
Perfect.
We're good? So this is probably a 1/2 pound of compost. You could put in more, all right? But so here's a bucket of water. So this bucket would be filled with water, like maybe 3/4 full. And then you would take this and you would slosh this up and down a lot, okay? You would slosh. And then you can take this and you can gently squeeze it. Don't rub it. Don't smack it. Don't crush it too hard. But you can gently massage it. And as you do that, all of the microbes will get washed off into the bucket. Now, the obvious question is, why would you not want to crush it or smash it? The reason is because that will kill your microbes. It's pretty easy to kill the microbes, okay? You'll never really kill all the bacteria, but you can certainly affect the fungus, and that's one of the most important microbes in there. And so you want to just massage it gently, and then you're going to have water, like here's a glass jar. Just dip the water out of the bucket and look at the color. The color of the compost should be a dark brown. My teacher, Elaine Ingham, she taught me that the color of the water should be the same color as a 70% chocolate bar, okay? And so if you pull out a 70% chocolate bar and you do a side-by-side comparison, like you're at the hardware store looking at different paint colors and you're matching your colors, that's what you want to do with this. And so you would take this compost extract and you would look at it, and if it's lighter than that, then what do you need to do? There's a couple of issues. First of all, if your compost is not good enough, it probably won't ever get to that dark color. But if you do have really good compost, then your color would get there if you do it enough. So if I did this sloshing thing 3 or 4 times, like for 5 minutes, and I'm going up and down and I'm squishing it, and then I dump this back in the compost, and then I get a new handful and put in. That would be the second time. And I do it again for 2 or 3 minutes. And then I dump this out and I get a third handful. That's the third time. So when you, after doing this 3 or 4 times, the color of the compost extract should be the color of a 70% chocolate bar. All right. And the reason it's that color is it's the humates. That's what you're looking for, the humates. It's the humic acid. And that humic acid is what is coloring the water. And humic acid comes from fungus. So if you have a compost that doesn't have any fungus food in it, it will probably never get that dark. If it's a bacterial dominant compost, then it will be a lighter color. And you'll be getting those kind of some beautiful golden bronze colors. And those would be the fulvic acids. So there's olnic acids, fulvic acids, and humic acids. Olnic acids are clear, and fulvic acids are like a beautiful brown. And then the humic acids, I might have mixed those up just now, but anyway, the humic acids are the dark brown ones, okay? Fulvics are clear. The humics are super dark, and the fulvics are kind of a in-between color. But you want that dark color because that tells you that you have a pretty good fungus, and those are going to they're going to be creating what you need in your soil. Now, how do you get it on your crop? Just get a normal watering can and just go water your crops. Put this on the soil. and it's for the soil. You want to get it on the soil surface, not necessarily on the plant leaves. It's fine if you get it on the plant leaves. It's not going to hurt anything, but that's not what it's for. If you want to get the right bacteria on plant surfaces, you would make a compost tea, which is a different process. It's a similar process, but it takes longer and it's different and it's more complicated. But anybody can make a compost. You don't have to know much to make a compost. All you have to do is learn how to do it the right way. And those are on those classes that I do for $8. This other, and then, so you make it right, and then you make the extract, which I just showed you how to do it, and then you pour it on your soils. That does a very similar same thing to your, the cattle would do as far as the regeneration goes. Okay. Let's just leave it at that. I may have got a little bit too complicated with that answer. But anybody who can't have cattle, if you do what I just explained, that will bring your succession to where you need to be. Let me just go back to ecological succession real quick. Okay, so here's my cursor on here. If you don't have any compost on your soils and you've been in a tillage system and you've been tilling your gardens, then you're right in here on this chart. All right. If you want to get over here where you have less weeds and you have to use less fertilizer, you will want to be adding more organisms. You need more fungus. You need more protozoa, more beneficial nematodes in this system. And you're going to get those from making the compost extract I just showed you how to do. Okay. If you're growing berry bushes and strawberries, you're going to be over here in this late mid succession. So if you have blackberries, raspberries, any of those crops that grow along forests in forest systems, strawberries, you're going to need to be over here in this later succession. And so how do you know where you are in succession? Well, you know, see what plants are naturally growing in your garden. If you leave your garden alone for 1 year, what's going to come up and grow? If it's just a bunch of annual weeds, annual flowering plants, and annual grasses, you're in early succession. Your ecosystem told you that. If a bunch of perennials start growing, you're somewhere in mid succession. If you have trees and shrubs and vines starting to grow, you're in late succession. Okay, Ezekiel, what's the next question?
Really poignant follow-up question to what you were just talking about. Using these methods that you've described, either cattle or composting, how long does it take you to get from early succession to mid-succession? What's a realistic time frame?
Okay, awesome question. I have two answers for it. First of all, we need to define what succession is, okay? Succession, your ecological succession of where your plants will naturally grow without a lot of work, it's not the plants that are growing. That is not the thing. The plants that are growing is the indicator of what succession you are in. But it doesn't mean you're actually like in that succession good enough that it's going to stay there from year to year, because nature is always moving. If it's moving towards bare earth, it's desertifying. If it's moving the other way towards the old growth forest, then it's doing what we want. It's the earth is becoming green. It's undesertifying, and it's trying to fix all of the ecological problems that we can deal with. Things like pollution and climate change and all that stuff. Okay, now, so understanding that, I think, is important to understand the practical application in our own gardens, which is what you really want me to say. One quick clarifier though, before I go there. The clarification is the thing that actually makes it in the succession where it is if the microbes are growing in the right balance in the soil. And the only way you can know that is if you have a microscope, which I have. My microscope is right here. And so I'm looking at soils all the time to know what succession they are in. And if I have the right balance of bacteria, fungus, the flagellates and amoebas and ciliates, those are the protozoa group. And then your the nematodes, all the beneficial nematodes, there's thousands of those. And then your microarthropods. And then it gets into the macros, which are even bigger guys like incatraids. But if we have a really good balance of those, depending on what the balance is, I can tell you what your succession is. So if you have mostly fungus, you're in late succession. If you have mostly bacteria and hardly any of those other predator groups, you're in early succession. So to grow food crops, you kind of want a balance of fungus and bacteria, okay? So how long does it take? It takes me 10 minutes to do the bucket trick that I just showed you with some compost, and then you go put it on your garden. Between the time of the bucket and putting on the garden, it goes on a microscope slide. I've got one right here. It goes on my microscope slide, and then it goes under my microscope, and I do a mathematical calculation, and I figure out how many microbes there are, and then I know how much of the stuff to put on my garden, and I can create the succession perfectly for the crop I'm wanting to grow. So it takes 10 minutes to actually make it happen. Okay, but is that practical for a home gardener? No, because you're going to need years of training to figure that out. You know, that's why we go to a dentist when somebody has a bad tooth, because they've had years of training. So what do you do in your own gardens? And how long does it take? You can convert this over so that you're using no man-made inputs within 3 years. All right. If you want to do it faster, there's a possibility you could do it in 1 year. But 3 to 5 years is more practical for most people without the training, without the microscope. 3 to 5 years, you're going to see almost no weeds, and you're going to understand that the weeds you do have are a blessing. And so you don't have to worry about them too much anymore. And you're going to be using no pesticides, no herbicides, no none of that stuff, no fertilizers, all that stuff we buy. You don't need any of it anymore after 3 to 5 years. But getting to that 3 to 5 year point, you can't make mistakes. We can't destroy the ecology and stop those 4 processes along the way. Because when we till the soil, we revert back to early succession every time we do that. So we start over every single year. Okay, that also is ruining the infiltration that can happen, because infiltration happens, and we'll probably talk about that next week. But you know, why and how to get our soils to infiltrate, we'll probably go into that next week, maybe the week after. But when we till the soil, that happens. So yeah, 3 to 5 years, but it can happen within 1 year. If you really want to jumpstart your system and you want to make it happen in 1 year so that next year you're there, that's where you need a professional with a microscope. That's why I do my laboratory work, is so that we can take a farm and we can convert it over, and you're going to do things completely differently. That's why I teach my boot camp. It's coming up in just a couple of weeks. Sign up for that. That's why I have my Patreon videos out there. If you signed up and watched all those videos, you would know most of this. And then ask me some clarifying questions. But that's why we're doing all of this education, is to take people so that they can do it in 1 year, 1 season. Okay, hopefully that answered that question. Go ahead, Zeke. Let's go to the next one.
Awesome. You said something there that's a really great segue into the next question on my list. You said it's important that we don't mess it up. So the next question was, is there any, and that I've gotten this question, have 9 people listed on here that have asked me a version of this question.
Okay, good.
Is there any place for tillage on a regenerative farm? What are the reasonable applications of the tool, if any? Do you think there's a meaningful difference between using a PTO rotor tiller and a plow? And what are your thoughts on hardpan broad forks? I know that was kind of big, but I've had 8 people ask me those kinds of questions.
Okay, yeah, so that's really good. Is there any place on a regenerative farm for any type of tillage? Absolutely, there is, but it's very, very small. Okay, what if I went to a place, and this is happening in my greenhouse right now because my ecological succession is happening so quick that I have to stop it a little bit. The best way to stop it a little bit is to do some tillage, but I'm going to do some very minimal tillage, and it will all be by hand. But what if you went to a new place, a brand new ecosystem, and you have a forest and you're trying to grow food in it, and it is so dominant with fungus that it will not grow a bunch of the crops that you like. So do you like kale? Do you like cabbage and broccoli? Do you like cauliflower? Those are early succession crops. Those are annuals. They're early succession crops. If you have beautiful, wonderful mycorrhizal fungus growing in your soil, it will infect those early succession crops and kill them, which is exactly what we want, because that'll kill all the weeds. Because weeds are the same ecologically as your brassicas, which are the cabbage, kale, broccoli, and all those. So how do you grow the cabbage, kale, and broccoli and still have really great, wonderful soil? Well, you just need to have different successions in your garden to grow the different crops. So maybe you would have 3 or 4 different garden plots. So yes, tillage is a good tool. Does it mean we need a 300 horsepower John Deere tractor with a 40-foot disc? No, we don't. What if you're a big farmer producing lots of cabbages? And this is where the principle of context comes in. And we're going to talk about the different principles of soil health in a later class, but one of them is context. If I am a farmer and I have to disc my field every year to grow those cabbage crops, the cabbages, kales, collards, all of those that are early succession, then those crops are out of context for the climate where I live. So if I'm trying to send out 50 semi-loads a year of those crops, because that's my farm, we really need to relocate to a place where the soils are more conducive to that, and then let those soils go ahead and colonize with mycorrhizal fungi that will grow strawberries and blackberries and a lot of the other crops like onions that need the mycorrhizal fungi. So sometimes, in a city setting at your house, whether you're city or rural, it doesn't matter, but in your garden at your house, it's not such a big deal to have a small plot where you are keeping it in kind of an early succession, and you might use some tillage once in a while to do that. But I mean, one of the greatest gardeners alive today is named Charles Dowding, and he lives in England, and he is growing the cole crops on, he's just putting down cardboard on grass to start his garden. He's putting on 3 or 4 inches of his compost that he makes himself, and he's growing those early succession crops right along with his later succession crops, and he never tills it, so he doesn't have to. So it's not like you have to till if you're going to grow those crops. There are ways to do it. But in my greenhouse right now, I have a bed, it's bed number 2, and I'm getting some infection in my cole crops. Some of my cabbages are not doing well, and I'm positive because I have a microscope and I can look at what's happening in the soil. So I have roots that are being infected with mycorrhizal fungi, which is a wonderful thing for mid and late succession crops, not for the early succession crops. So yes, tillage can have a place on a regenerative farm, but probably less than 1% of the time. and it's not something that you would do a lot. You would do it very, very seldom, because when you till, you kill the microbes that are so hard to grow in your and take a long time to get established. So I don't think I answered all of that question. Can you remind me some more parts of that question? I'd like to answer it a little bit better.
Yeah, so just one thing for context, a couple of these people, their questions implied that they were wondering if when you're first starting your farm and you're working with hardpan or very low quality soils that are highly compacted, if it would be a good idea to use hardpan broad forks, a once over with a rototiller to get biological material into the soil and to aerate the soil for your first year of planting.
Okay, so yes, you certainly could do that. If you're just starting out a farm, you have a brand new piece of ground, you certainly could take a big machine through there, and you could take some shanks in there behind a tractor. You could rip it 3 feet deep. But if you're going to go to that much trouble, make your extract of some good compost and get the biology in there when you do it. I don't know that it's that beneficial to actually use the rototiller. You know, rototillers can still be bought. You can go rent them. You can use them. I have a great friend who makes a lot of money every year. He may be on this class tonight, but he rents out rototillers in the spring. And I certainly am not about telling you to not rototill, except that it may not be doing what you want to do. I absolutely don't want to put somebody out of business who that's their business. But there are better ways to grow great gardens, because if you're using a rototiller, you are churning everything up. Broad forks are much less invasive. They're not going to break all the mycorrhizal colonies that are happening in the soil. But when you do it, if you're going to break up the soil, figure out a way to incorporate that compost tea or compost extract is what I meant to say, the compost extract at the same time when you break that soil open. You want to use that opportunity, because the more you work the soil, the more microbes you are killing when you do that. But no, you certainly don't have to. That can be expensive. It can cost you a lot of time and money to do that soil work. So when you're first starting, all you really need to do is go out there and just put down 4 or 5 inches of wood chips or a compost material and just put your transplants in it. And when you do that, get your compost extract on there, inoculate it, the compost or the wood chips, with these microbes, and your plants will take off and they will start growing. Now, when you're first starting, sometimes your mineral cycle is not working. And so you do need some fertilizer for the first year or two. I've had people say, oh, I tried a lasagna garden method and it didn't work. My plants didn't have any nitrogen. Well, if your plants didn't have nitrogen, then it was your responsibility to fertilize them with some nitrogen. Go get you some blood meal and fertilize them. Get you some fish hydrolysate and fertilize them. If you're worried about chemicals and you don't want to use them, then use the organic fertilizers. Go get a bag of chicken feed from the store, a 19% chicken food. Put that in there as a fertilizer to feed your microbes and get everything growing. That will jumpstart and get your mineral cycle working. But no, you don't have to till it up. I've started a lot of gardens with not tilling at all. I have a greenhouse out here. In fact, this is worth scrolling down. Let me go find this picture. Last year, I started a small greenhouse and I put in about 12 inches of old rotten hay. Okay, it's coming, it's coming, it's coming. At some point through these 20 weeks, we will talk about every one of these slides, guaranteed. Oh, it went back to the top. Man, my computer skills are not too good. Okay, that's it right there. here we go. So this garden, this was compacted hard clay. If you look to the right of that picture, to the far right, you can see the top of the big Wallapini greenhouse where I grow most of my stuff. This little greenhouse that I'm standing in front of right here, that was the place where I pushed all the rocks through. I drove over that 1,000 times in the construction of the big Wallapini greenhouse that's on the right side. And so by the time I leveled this off, it was thoroughly, absolutely destroyed. There was no topsoil here, and I didn't put any topsoil on that garden at all. And what did I do? I put in 1 foot of hay in that greenhouse, and it was pretty thick, compacted hay. But I put it in there, and I only pulled like 7 weeds out of that. So I put the hay in there, and I irrigated it. I put 3 sprinklers in there. I left the sprinklers on for 3 days so that hay got absolutely saturated. And then I put in like 6 or 8 drip lines in there. You can see them behind me there on the ground, those black drip lines for irrigation. And then I made a hole in the hay. I just pulled the hay apart, and I put a transplant down in the hay. And then I turned on the irrigation lines, and I grew a big crop. Let me go to the next slide there. This is later in the year, and those are the crops I had in there. That's me holding a cantaloupe. I'm seeing if it's ripe. It wasn't ripe yet, but it did ripen, and we ate it. But we had cantaloupe, cucumbers, and a whole bunch of different kinds of squashes. And this is a picture one day when we harvested squash out of there. So there's Hubbards and crooknecks, and there's a pumpkin. Yeah, we had pumpkins in there. I forgot about those. But we had 3 or 4 different types of melons in there. I had muskmelons, watermelons, cantaloupes, and then some of these big, beautiful other types of winter squashes. And with only 7 weeds, we had a good harvest. I tilled nothing. I broke up no hard pans. It was 1 foot of hay. And then I just put the plants in there. Now, I did not fertilize that garden. I think it would have needed fertilizer, except for one thing. The little cups I put in, these plant transplants were in 4-inch wide pots that were 5 inches tall. Okay, they were about the size of a quart jar. And they were a biodegradable pot. And when I put the plants in there and I put all the seeds in these little pots, okay? But that was a potting mix that I made, and it had a mix. It had compost, it had worm castings, and a lot of those had earthworms in them when I put the seed in. And it had a mix for every 5-gallon bucket of the mix that I made up that I put in the pots. I would add in a tablespoon of shredded eggshells, a tablespoon of bone meal, a tablespoon of azomite. That is a product that I buy, but it's just you can get it like at a lot of places, but it's just an ancient seabed dirt, and it's full of lots of trace minerals. And then it had bone meal, blood meal, azomite, alfalfa meal, and I forgot what I said, but there were 5 things, and I think I got them all. But so, yeah, that's what was in there. And so that was quite a bit of fertilizer that was in the pot. And so I put the seed in there, grew them in the greenhouse until there was a nice little plant on top, carried them out, moved the hay back, stuck it in there, and that was it. And we went back and harvested. And while I was checking on things to harvest, I pulled about 7 weeds. There were probably 20 or 30 other weeds, but I didn't care. I didn't worry about it. So that was a weed-free garden, and it was easy, and we got a ton of food out of it. We're still eating squashes that are in the root cellar from that greenhouse. Now, will I fertilize it next year? Probably not. What I'm going to do in the next couple of weeks, when my freezing temperatures are they're starting to go away now because spring is coming, I'm going to take a whole bunch of earthworms. I'm going to probably put 5 pounds of earthworms in that greenhouse, 17 feet wide, 100 feet long. I'll scatter those in there, and I'll just move back the hay in probably 10 different places, put a handful of earthworms in there, and then the earthworms will start tilling that soil. And right or maybe before I plant or when I plant my new transplants in there this year, I will pull a soil sample from that greenhouse. I'll take a plug from probably 10 places in the greenhouse. I'll mix it all up. I'll look at it under my microscope. And if I have a lot of fungus and a lot of beneficial nematodes and a lot of protozoa, I will know I don't need to put in any fertilizer, because those organisms will be doing the fertilizer for me, which means that my mineral cycle is working. My soil is functioning because the mineral cycle is working, so I won't need any fertilizer. Okay, Ezekiel, did I answer that question good enough?
I think so, yes. I think
Okay.
it could do with a couple of Patreon videos because there's some depth there, but I think you answered it good.
Okay.
The next one. How do you start your garden in mid-succession? What are the basic steps if you're already there?
Okay, if you're already in mid-succession. So first of all, how do you know you're in mid-succession? And I'll answer that. You know that because the plants that are growing are, you probably have some perennial plants that are growing from year to year, and those are an indicator that you're in mid-succession. Okay, so the way I'm understanding this question is you're asking me, how do I just get my garden going? And I would just want to leave it in mid-succession because it's already there. Here's what you do. Because you're in mid-succession. Okay, I know you're in mid-succession because you have perennial plants growing, but you don't want a perennial plant growing in your garden where you're going to be growing your annual plants, maybe. Okay, actually it's a good idea to have those perennials growing, but so it depends on what you want to do. This starts getting more complicated, but the easy thing to do is if you have clovers and alfalfa, you have the tall sweet clover, and you have a bunch of grasses that are growing in your garden, and that's telling you that you're in mid-succession. All right, I would just put down a cardboard on a strip. If I wanted my garden to be 5 feet wide and 10 feet long, I'd put cardboard down 5 feet wide, 10 feet long. That will kill out those fast growing perennials, and it will give your garden plants that you want to grow the chance to start growing. Okay, put down your cardboard and then put on 3 or 4 inches of compost, and take your transplants that you want to grow and put them in that in your compost, and keep it watered and enjoy your garden. That's how I would do it. Now, does that throw it back to early succession because you killed the perennials? No, because the plant that's growing is only an indicator of what's happening in your soil, like I said before. So you would be in mid-succession because those plants aren't growing unless you have the organisms in the soil, like the protozoa, the beneficial nematodes, the fungus, and that's why your perennials are growing. Okay, but your vegetables and a lot of your food crops will thrive in there too, except for your brassicas, and they want a little bit less on the left side. Hopefully that answered that question. Hopefully that is what you were actually asking. If not, ask again, and I'll change my answer to meet what you're really asking.
Okay, awesome. The next question, and I've got this from a couple people in different environments around the US.
Okay.
So like I've gotten 2 questions of this from the northern Midwest, and I've gotten 5 from the Great Basin and 1 from the West Coast, but the question's the same.
Okay.
How do you use cover crops as fertilizer, especially on a home scale with minimal equipment, but also on a larger scale?
Okay, small scale first. You don't really, I hate to say this because it's a lie, but you on a home scale, you probably don't have room to grow a big cover crop. Okay. So what would you do? You would collect all the organic matter you can find, and then you could just make compost, and you would use the compost to put on the garden, and that would do the same thing as rolling down a cover crop. okay? On a large scale, meaning acres, okay? If you're less than 1 acre, you probably just have a nice big garden that you can do it all by hand. And you can do it by hand because you're not tilling and you are not weeding. After 3 to 5 years, your weed problem is gone. And if it's not, you needed a mentor along the way. So just, that's why we're doing this class, is so you can have success. But over an acre, you're going to be using some equipment. On anything less than 5 acres, you could use a 4-wheeler, and that's enough equipment. You can even use your car. I know a guy in Missouri who was this old man. He did more farming with a car than a lot of people get done. He would hook his implements to a car and just pull them through the field, which is pretty hilarious. But that is not answering this question. So, but you can think outside the box just a little bit. But say you had 5, 10, 20, 50, 300 acres, get you a tractor and use the tractor. But they have these things called a roller crimper. Okay, a roller crimper. You can look those up online. And so so if you had a tractor and you had a no-till planter, you could get a little tiny old-fashioned one that people don't want anymore. If you get new ones, they're pretty expensive. But if you're thousands of acres, it's what you need. But on a more of a homestead scale of 10 to 50 acres, get some older used equipment. But if you had a no-till drill, that means a grain planter, or okay, so a tractor, a no-till drill, and a roller crimper. Those are the 3 pieces of equipment you need to do this. So fertilizer equals cover crops equal fertilizer, and it's just a cycle, okay? Sometimes an edible crop can be your cover crop. So if you grew a great big giant garden plot or even acres of peas, and then you went out and you harvested all the peas, that's an edible crop. And then you could just roll that crop down flat on the ground. So it rolls down. And it is the same thing as what I did behind me in that picture right there. I took an old hay, put it on the ground. It created this thick mat. When I first put it in there, some of it was really tall, like 3 feet. But after walking on it, then it was smashed down to 1 foot thick. That's essentially what you're doing with a cover crop that you grow. So let's talk about a cornfield. Let's say you grew a big garden that was 20 feet wide and 50 feet long, and it was corn. When that corn is tasseling, and that's when the male flower comes out of the top of the corn, and then the ear, that's the female flower that comes out of the side of the corn that produces the edible part that you eat. When those flowers come out, about the time you can see them, you look across your field and you can see them, that's the time to plant your cover crop in the corn. And that's why I said when I first started this is it was a lie, because you do want to plant cover crops even on a home scale. So when the crop you're growing is at the right stage, that's when you want to be planting your cover crop. And so let's say if it was green beans, let's say you grew bush beans, and they get about maybe 1 foot high or whatever, 18 inches high. When your beans are ready to pick your first crop, because you'll be able to pick them for 3 or 4 weeks, right? Because they'll keep flowering for a while and you'll be picking them. But when your first beans are ready to pick, that's when you plant your seeds for your next crop, for your cover crop. So a green bean planted in May, you're going to be picking it towards the end of June or whenever, depending on your climate and all that. But let's say you start picking it at the end of June, and you're picking it through 4 weeks of the end of June, 3 weeks of July. The last week of July, it's done and it's finished. Your cover crop at that time should be the same size as those beans. So it's growing, growing, growing while you're picking. And then it becomes the same size. So a good cover crop to plant with the beans would be a big crop of daikon radishes. And then in August, you could pick all those big old daikon radishes and do whatever with them. Or you could leave them there and you could take your roller crimper and you could roll them down. on top of the soil. Or if you have an early frost, because see where I live, we can get our frosts in August. The last week of August, we can get a killing frost here, which gives us a very short growing season. But I don't even have to roll down that daikon radish because the cold weather in September and October is going to kill them. But they become the best worm food in the world, and they will make a big old giant hole way down in the ground because throughout the winter they will rot away. The earthworms and all the other microbes will eat them, and then when it rains and the snow melts in the spring, all that water goes in, and suddenly I don't have an infiltration problem anymore. So when I get 10 inches of rain, I don't have floods on my farm because the water all soaked into the ground. So that's the end of my answer. I don't know if that answered it, but I hope it did.
I think it did pretty good. The next question, and this might be our last one because of time restraints, is suggestions for aphid control on brassicas and by extension other early succession, specifically in regards to manipulating life cycles and timing the application of controlling agents in shorter growing cycles, such as in the north and the west of the United States.
Okay, so aphids. There's a thing called, what is it called? It's called Castile soap. I wish I knew how to spell it, but Castile soap is pretty common. I think you could get it at almost any store that sells soap. Castile soap, it comes in a liquid or it comes in a bar of soap. And normally we have some liquid around, and so a couple of drops of Castile soap in just a little pump up sprayer, and you just get a sprayer from anywhere, like Walmart. You get a 3-gallon sprayer, or if you're a very small gardener, you could get a 1-gallon sprayer with a little pump up. And so you would fill it full of water, fill your sprayer with water, and put 4 or 5 drops of soap, 1 drop, whatever, 4 or 5 drops, it doesn't matter. You just put some soap in and then pump it up until it's spraying out, and you go spray it on your plants. Now, this soap is basically edible. It's not going to hurt anything. It doesn't kill the microbes. It doesn't kill people. It's the safest soap in the world. It's normally made from coconut oil, which you can eat. And so what it does is the Castile soap will, it suffocates the aphid because the aphid breathes through their skin. They just absorb air through their skin. They don't have lungs. They can't take a big breath. They can't do that. And so, because they don't have lungs, they don't have that organ in their body. They don't have a diaphragm. And so all you have to do is spray them, and the soap will coat their body and they die. Like in 24 hours, they're dead. And so if you still see aphids after 24 hours, spray them again. 3 or 4 applications will eradicate all aphids. Having lots of ladybugs in your garden, keeping ladybugs in your garden is a really good idea. Okay, I've had great luck with Castile soap to control aphids. Here's the other thing. If you have aphids, like a lot of them, you have too much nitrogen in your soil. And if you have too much nitrogen, well, let me be clear. It's not just any nitrogen, it's nitrate, okay? You have too much nitrate in your garden. In fact, I have a slide that will show this. What you need is more ammonium. You need more of a balance of ammonium. Let's go up here. It was actually that slide, it was part of our lecture for today, but we didn't really get into it. Look at this slide. If you have lots of aphids, then it's creating, it's because of NO3. All right, now look over here where my cursor is on bacteria. Bacteria is NO3, which means nitrate. And if you are doing things in your garden that are creating lots of bacteria, you're going to have lots of NO3. So aphids are an ecological indicator that you have way too much bacteria in your soil, or you've been adding too much nitrate, which is in a man-made form, like Miracle-Gro or whatever. Okay, if you add a lot of that nitrogen fertilizer, then you have lots of NO3. So look at the bottom of the chart down here where my cursor is. NO3 is weed food. So you're going to have a lot of weeds, and you're going to have lots of aphids. All right. So you need to have a lot more of the ammonium. So if you look over here, NH4 is ammonium. Well, look at fungi, protozoa, nematodes, microarthropods. Those guys are all NH4. Their bodies are made out of lots of NH4, and their byproducts, their waste, their poop is NH4. And so that creates more of the mid-succession where we want to be. So if you have lots of aphids, what the ecology is telling you is that you are in early succession. Okay, Zeke, move forward.
Okay. A follow-up question to that. Are there any ups to having aphids, or are they mostly bad?
I've never thought of it. They probably are some protein if you ate them. If you're, and everybody's saying ooh right now, but I'm actually serious.
I've eaten them.
In times of famine, if you ate them, I don't know, what does NO3 and nitrate, what does that equal in terms of protein? Maybe none, I don't know. They're not going to hurt you if you eat them. If you have aphids on your food, it's good. And that's not a bad thing, because it shows you that you don't have poisons on your food that is killing the. I like bugs on my food because you can wash them off if you don't want to eat them, but they're an indicator that it's not full of pesticides. So that's not a bad thing. But I don't think that was the question. I think your question was more likely, like, is it really bad to have aphids in your garden? I love having a few aphids around. My Wallapini may have 20,000 aphids right now in there, but it's such a low number, because 20,000 aphids that means we walk through and we don't see any. Like I harvested lettuce today, it was absolutely aphid free. There were no aphids on it. But if I do see aphids starting to grow in there, then I know I have lots of NO3. My bacteria to fungal ratio is out of balance, and I am desertifying in my greenhouse. And so I need to add more protozoa and nematodes and fungus and microarthropods. And how do you do that? Well, that's a discussion for a later class. But yeah, I mean, if you're trying to sell crops, aphids are bad, because if a person buys something from you and there's aphids on it, they probably won't come back to you and buy it again, because that's the way our American society is. So they're bad in that way, but ecologically, they're a wonderful indicator to know what's happening. Yes, they can. If you are way out of balance ecologically, if your mineral cycle is not working right, then you're probably going to have infestations of aphids. And yeah, they can be devastating to peach trees and other things, but that's just an indicator that you got to do some stuff. And you can fix that in 10 minutes with a really good tea. The symptoms may not go away. It may take a few weeks to see the aphids leave, but you can get rid of the aphids right now with the Castile soap on a peach tree. So they're super easy to control. Okay, so yeah, let's move on.
Awesome. Okay. Does a weed barrier, as in a waterproof tarp, on food crops prohibit nutrient cycling over long periods? Should we, if we're using this, should we be pulling it back and top dressing during the winter?
So yes, the answer is yes. It does stop nutrient cycle over time. It kills a lot of your microbes. It'll stop your water cycle. There's a lot of bad things about the weed barrier. There's no reason for a weed barrier. Weed barriers are ancient technology. Don't use them anymore unless you are trying to eradicate something right now. You're doing something really major. You're trying to get rid of something like your early succession terrible weeds, like quackgrass is an early succession bad weed. Morning glory family and the bindweeds, those are super bad. And tarping can help with that. But I would try to get away from that as soon as possible, because your nutrient cycling and your water cycle is not going to work properly if you have those weed barriers on there. You want that transevaporation. I used that term earlier. There needs to be a better term for this, and I don't know what it is. But you want that the nitrogen cycle. You want that working up from the leaves down, up and down, and all those microbes up and down the stems and the plants into the root zone. You want the what's the other one? So there's your nitrogen is moving, the carbon cycle, your carbon dioxide, you want that flowing all the way. When we have plastic barriers in there, it screws stuff up. I don't like it. It messes it up. So for a temporary thing for a year or two, it's fine. But if you can get a large supply of old rotten hay or wood chips, just use that, because then all your cycles are working.
And so what do you think about a tarp that was water soluble and allows gases through? Would that be better?
Yeah, they have those breathable tarps. I still don't like them because even if those cycles are working with them, I don't like them because I have to purchase it in the first place. And there's no benefit. You can do exactly the same thing with the wood chips and the compost. And you may have to buy those too. You know, get creative and figure out a way to round stuff up where you don't have to buy stuff. But if you know, I mean, I could be the editor of the Cheapskate Gazette too, so whatever. So if you come from a world where you just want to spend the money and do it, and you're going to make an investment, invest in the wood chips, invest in the compost materials.
Okay, and that's a good segue into the next one. Can you put wood chips on top of cardboard? And when planting with cardboard, do you make holes through it to transplant, or do you just transplant on top of the material you put on top of the cardboard? What's our best practices with that?
Okay, I've had a couple of people private message me during the week about the cardboard after hearing me talk about cardboard last week. So let me be really clear. The only reason you're going to put the cardboard down in the first place is if there is a weed to kill. Okay, if you don't have any weeds to kill on your soil, just go put 3 to 5 inches of compost down or wood chips down, and then put transplants in there. Like, take your transplant, it's the size of this jar, move your wood chips out of the way, put this down to the same level of the wood chips, move your wood chips around it, water it, and you're good to go. Okay, now if there's a noxious weed and you put a hole through the cardboard, the weed's just going to come right out. So never, ever, 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 never put holes through the cardboard, because that defeats the purpose of why you have it. So if your pot that you're transplanting, like that you're putting in the soil, if it's 1 inch deep, then your compost on top needs to be at least 1 inch, so that the compost comes up to the same depth. If your pot is 5 or 6 inches deep, then your compost or wood chips need to be 5 inches deep, or old hay or whatever, so that when you move it back, you can put this in there. Okay. Now, sometimes I will use a drill, and I will drill holes in the ground, and then I'll just put them in, and that's how I dig my holes. But that's not going to work for hay or brand new wood chips. Your material has to be pretty decomposed to use the drill auger, and I'll be showing that in future classes on how to use that drill auger.
Well, the last question I have in my list here is how do you get your land more infiltratable? How do you increase water infiltration into your soil? And I know that's the topic of our next class, so I don't know if you want to get into it right now.
Yeah, so you do what I've already taught you. Put the 4 or 5 inches of compost on there. Don't till your soil. The only reason you would till it is if you were going to rip holes through it super deep. And at that time, you would inject compost tea or compost extract. I keep saying tea, but really it's extract going down in that soil. and you would do it at the same time. But the only reason you do that is if it was really drastic. 90% of the time you would not do anything to the soil, just cover it. Start growing plants in it. Always growing plants in it. You never have bare soil. Never have bare soil. Always keep the soil covered. And yeah, so that's how you make it more. That's how you fix infiltration. And yeah, the southern Utah area where you live, Ezekiel, when that you got that 10 inches of rain in one day, matter of hours, I think it was, it caused all those flash floods. If all that wild ground, all that wild BLM ground, it could be infiltrating water. It's not hard to do. It just takes proper management, but it is not being managed that way. It's being managed for desertification because of lack of education, probably. And what is causing the desertification is overgrazing. And so we need to have more grazing animals on smaller pieces of land for shorter periods of time, instead of having less animals that are just walking around eating whatever they want all the time. But that's how we create an infiltration, a soil that infiltrates. Okay, any more questions? I can take a couple more minutes. Our time's basically up, but I can take a couple more. I'll just answer them really quick.
So is it a good idea to mix, if you were using mostly the hay method, would it be a good idea to mix in wood chips and compostable items?
No, but yes. But that is one of the best questions we've had tonight, actually, because use what you have, use what is cheap, use what is available, use what is in your area. There's a guy who created a gardening method called hugelkultur, and he took all these tree branches and he put them in a ditch, and then he covered them with a bunch of stuff. And now hugelkultur is a gardening method. And you know what people do now? They go out and they buy branches to do it. And the guy who invented the whole thing, he said, oh my goodness, this has got clear out of hand. The reason I did that is I had so many branches, I didn't know how to get rid of them. So that is hilarious to me. It's so funny. We've got to understand that use nature. Don't burn gasoline to go buy a bunch of stuff and spend hard-earned money on a whole bunch of materials to do something because somebody had a good idea. What you need to do is use the natural resources that are already being thrown away, that people are burning, that they're getting rid of. Just use those natural resources. Stop filling the landfills. Stop causing more smoke and pollution by burning stuff. Stop contributing to the nitrates and the NO3s, the bacteria foods. Stop all of that and just put that stuff in our garden and then let nature self-regulate it. You will get the same results if it's just old hay, if it's just wood chips, if it's a mix of all three. It doesn't matter. It doesn't matter. All right, what else we got?
Best practice for planting trees at this time of year in a rocky hillside. I believe this question's coming from northern Utah.
Okay. If it is from northern Utah, go to Cook's Nursery and ask them about tree planting and what kinds of trees. They are the experts for northern Utah on planting trees. But anytime you plant a tree, dig your hole at least twice as deep as your roots are and twice as big. If it's in a pot, then it's easy, because if your pot is 12 inches across, then you're going to dig a 24-inch hole. If it's 12 inches deep, dig a 24-inch hole deep. So you would have a twice as big. Now, depending on if you put amendments in that soil to mix in, that comes down to your local tree experts who know your soils. And I don't even know how to tell. If you told me your town that you live in, I couldn't tell you. But you do have local people who can. This is where your university extension agents are really helpful. This is where your master gardening experts are really helpful. And your local nurseries who are selling trees to your local area are helpful. Who is not helpful? The Walmarts are not helpful. The Home Depots are not helpful. The Lowe's nurseries are not helpful. Those are just regular people who have a job at those stores. 90% of the time, they are not the experts on those trees. And sometimes they will answer you as if they are. It does not mean they are. You're going to need to do a little bit of research to find out. In fact, Walmart nursery is so unhelpful. When I lived in Missouri, I would go to the garden section every year in the springtime and I would look at fruit trees. They would sell fruit trees there that would die in that zone. It would get cold in northern Missouri. It could get down to like a zone 4, normally zone 5, but it could have zone 4 temperatures. And they had all kinds of zone 5 fruit trees there all the time. I guess it was great. They'd keep selling fruit trees if people would keep buying them because they'd winter kill every year. And they wouldn't every year, but every 4 or 5 years they would. And so it becomes a miserable thing to try to go to just a local big box store and buy trees. And you assume that if they're selling it, they're going to grow in your area. That is the wrong assumption.
One last question here before we have to end. Our terrace builder landscaper put ground cover down and then put about 4 inches of wood chips on top in a newly area after building the house.
Yeah.
What can I do with this land?
Make a compost, and you need to make a good compost. If you're one of my Patreon people, you already know how because all the videos are on there. And then inoculate that because it's got the wood chips on there. Just inoculate it really good with your compost extract. And then you can do anything you want with it. Grow vegetables on it, grow fruit trees on it, grow anything you want. Don't worry about the landscape fabric. It's already in place. Leave it there. It's not a big problem. But the wood chips are on there. I would just go ahead and add some more, maybe 1 or 2 inches of compost on there. Or if it's a big area, just apply your compost extract and then plant your plants in there. If you planted some fast growing plants like radishes could be a great indicator for anybody in any garden anywhere. Plant your radishes. If they grow really good in 30 to 40 days and they're nice and green and they're beautiful and they make a nice radish, then your ecosystem's working. Your 4 ecosystem processes are probably working fine because they're growing, they're thriving, they're looking good. But if your mineral cycle isn't working, your radishes will grow slowly. They will have yellow leaves. That will tell you really fast that you need to add a lot more of your compost extract to get a lot more of your fungus, protozoa, nematodes, microarthropods in there so that you're producing more of the NH4. You got to get that ammonium in there. If you don't know what I'm talking about, look at our slide right here. And I'm just referring to that right there. You know, you got to get those in there. And at the same time, add more nitrogen in the form of a fish hydrolysate, which is just a gallon jug you buy at a Walmart garden center, like an Alaskan fish fertilizer, or which is the same thing. There's just different brands called different things. You could also add some blood meal. That would be a good source of, and just follow the directions. But once you get your soil functioning, you're never going to have to mess around with all that stuff again. It's just going to keep functioning fine, you know.
One last question for reals, and this can really be our last one. I've got a couple questions about when you say that when you're planting a tree and you dig down twice as deep, do you put the tree halfway down that hole with loose dirt around it, or do you put it all the way to the bottom of that hole and cover it up twice as deep?
Okay, it's a good thing you asked that question because you almost killed your tree. You always plant trees at the same level as they were before, like growing before. So if there's no dirt around it, it's called bare root. You can see all the roots, but you look at the trunk of the tree, and just above the roots, the bark will change. It'll be a different color, maybe a different texture. That's where the soil line was before. So when you plant the tree, always plant trees, all trees, at the same level they were growing before you transplanted them. If they're in a pot, then that's easy because you just put the soil at the top of the root ball soil at the same level as your outside ground. So you're going to dig it twice as deep, but you're going to fill it back in with loose dirt. That's to help give the roots a good start so they can start growing out. So good question.
I think we're about out of time here. Appreciate you.
Okay, if you didn't get your question answered, Ezekiel, can you put up our Facebook thing that you created? Put it on like in the chat or something so people can see it.
Let me grab that link. I've been having people email me questions throughout the week, but I will. That's probably a good idea as well.
Okay, good. Yeah. Okay, so we created a Facebook group. I don't know why, because I'm not smart enough to run Facebook, although I've been on Facebook for about a year. And I'm helping people with gardens and so forth. So Ezekiel created this special group for it. And anyway, here's our upcoming events. Boot camp. Go to www.georgicrevolution.com to see more and to get more questions answered, to see all of our classes, and to sign up for anything that you need here. The goal here is to help you grow food, because I don't believe in the world we live in that the food will always be at restaurants and grocery stores. I don't really think we will see a widespread famine in the United States, but it could happen. And so I want to just help as many people feed themselves as possible. And that's why we are doing this. And thank you for coming tonight. Next week, we will be here again, same time, same place. And I'm not sure what our subject will be yet next week. I don't really, I mean, it could be one of 20 things. I'm kind of thinking about talking about water infiltration. Maybe we'll talk about the 5 spheres within the soil, but maybe we ought to talk about what to plant right now too. But that's going to change depending on your climate, but we could talk about that.
The Facebook link is in the chat. It's facebook.com/Georgic Revolution.
Okay.
Thank you so much, you guys.
Thank you, everybody. And good night. End meeting for all.